So a turning point of a function is a point on the graph of the function where there's either a local maximum or a local minimum. Okay, so it's the points where the function changes from increasing to decreasing or from decreasing to increasing. So the turning points of this function are the points -2, 2 and 3, -2. So here we have a local maximum, here we have a local minimum. The x-intercepts of a function are the places where the function crosses the x-axis. So in this case, -4.5, 0.5, and 5 are the x-intercepts of this function. Okay, let's do another example. Okay, in this problem here, as we traverse along the graph, we see right here we have a local minimum, right here we have a local maximum, and right here we have a local minimum. So these 3 points are our turning points. The x-intercepts are these two x-coordinates where the function crosses the x-axis. Okay, find the turning points and x-intercepts of this function. Okay, so press pause and work on this alone. So this is the answer that you should have gotten. So you should have graphed this parabola, y equals x squared minus 9, which is just the graph of y equals x squared shifted down by 9 units. So you get that the turning point is the vertex, which is the point 0, -9, and the x-intercepts are -3 and 3. Again, so in case you didn't get that, the way you get those is you set the function, to get the x-intercepts, you set the function equal to 0. And the solutions to this are, so we need to figure out what minus 9 is 0. Well, 3 squared minus 9 and -3 squared minus 9 are both 0. So those two are our x-intercepts. Okay, let's look at an important property of turning points and x-intercepts. Okay, the largest number of x-intercepts that a polynomial can have is equal to the degree of the polynomial. And that's because the x-intercepts come from the factors of the polynomial, and the largest number of factors that you can have is equal to the degree. Okay, using calculus, it's very easy to show that the largest number of turning points a polynomial can have is 1 less than the degree. Okay, so the largest for x-intercepts is the degree, the largest for turning points is 1 less than the degree. So for this function here, this polynomial, the largest number of x-intercepts we can have is equal to 4, and the largest number of turning points this can have is equal to 3, because that's 1 less than 4. Let's look at another example to illustrate this. Okay, so this polynomial here has 1, 2, 3, 4 turning points. Okay, so 4 turning points. So I know that this cannot be a degree 1 polynomial because the most turning points a degree 1 polynomial can have is 0. Okay, so a degree 1 polynomial can't have turning points. A degree 2, the most it can have is 1. Degree 3, the most it can have is 2, and so on. So I know that the smallest degree that this polynomial can be is degree 5. Okay, so a degree 5 polynomial is allowed to have 4 turning points. Again, a degree 4 isn't allowed to have 4, a degree 3 isn't allowed to have 4, and so on. Furthermore, this has nothing to do with turning points, but I also know that this polynomial is an odd degree polynomial because of the way the end behavior goes. When the end behavior is going in opposite directions, I know it's an odd degree polynomial.